Number 25 wants you to take a complex number and write it in polar form. So now we're on to our complex number problems. So remember that this complex number is in the form a plus bi. And so if you remember what the polar form of a complex number looks like, it looks like r, and then it's cosine theta plus I sine theta. Okay, and so r, you know, is the square root of, and in this case we would say a squared plus b squared. So r is going to be the square root of 2 times the square root of 3 squared plus 2 squared, and you leave off the I because it's just b squared. R becomes 4 times 3, or 12, plus 4, which is the square root of 16, which is equal to 4. Now you can see right now that the answer must be A, but I don't want you to stop there because it might not be obvious, or you might not have a multiple choice. So you need to find the angle too. Okay, so don't just put A down. You need to find out how you get pi over 6 as your angle. So the angle, remember, is the inverse tangent of B over A, which is equal to the inverse tangent of 2 over 2 square root of 3, which is equal to the inverse tangent of square root of 3 over 3. Now, you have to look at the quadrant. Again, this is quadrant 1. It would be in quadrant 1. So the tangent would be, inverse tangent would be, what is the angle at square root of 3 over 3? It would be pi over 6. So your equation, or in polar form, it would be r, which is, we found out it was 4, and then cosine pi over 6 plus I sine of pi over 6. It's getting loud out here with the lawnmowers, and the birds are going crazy. I think I'm going to head inside. Number 26 wants you to write in a rectangular form 4 cosine 2 pi over 3 plus I sine 2 pi over 3. Now these are easy when you're going from polar to rectangular complex numbers. You're just going to multiply and calculate. So this becomes 4 cosine 2 pi over 3 plus 4 I sine of 2 pi over 3. Now cosine of 2 pi over 3 is negative 1/2. So negative 1/2 plus I times 4, and sine of 2 pi over 3 is positive square root of 3 over 2. So that would be 2 square root of 3. So your answer is negative 2 plus 2 times the square root of 3i. Negative 2 plus 2, and they split it up. Negative 2 plus 2i square root of 3. So the right answer was B. For 25, the right answer was A. Okay, I told you that. Okay, let's see if we can do number 27. Number 27 wants you to multiply these two polar complex numbers in polar form. And remember, we had a formula for that. You would multiply the two outside, and then you add the angles. So it would become 5 times 5, and you have cosine of 11 pi over 6 plus 5 pi over 3 plus I sine of 11 pi over 6 plus 5 pi over 3. So that's 25, and then the cosine of, let's see, that's 16. Oh, wait, we have to multiply this by 2, right? So 21 pi over 3 plus I sine of 21 pi. Oops, too many lines there. 21 pi over, it's over 6, sorry, over 6. We can simplify that to 7 pi over 3. So cosine of 7 pi over 3 plus I sine of 7 pi over 3. and that's all by 25. Now you might say, I can't do 7 pi over 3. Yes, you can. 7 pi over 3, you just go around the unit circle. This is 6 pi over 3, right? So, because it's like pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3 gives you 2 pi, right? So one more pi over 3 would be your 7 pi, which is equivalent to just pi over 3. It's just one time around the unit circle plus. So what is the cosine of pi over 3? 1/2, and not 1/3, 1/2. And sine is the square root of 3 over 2. So we have 25 on the outside, and let's see, 7 pi over, okay, so I messed this up, sorry. It's 7 pi over 2, because when you simplify that, you're dividing by 3, so sorry, over 7 pi over 2, screwed that up. So we're not talking about those angles there. 7 pi over 2, let's go around again. Okay, this is pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2, which is equivalent to 3 pi over 2. All right, so now it's 25. Correctly, 7 pi over 2 would give, cosine of 7 pi over 2 would give you 0, minus I, and this is negative, or plus I, and this is negative 1. So you got negative 25I. So that is your answer, and that is D. Okay, I'll stop there.